Good afternoon, everyone. Thank you all for coming, and thanks to the PyTorch Foundation for having me out. My name is Doug Lehr. I'm a principal engineer at AMD. My primary focus is AI model optimization, AI performance optimization on the PyTorch framework with ROCm. And so today, I'm going to talk to you about some changes to ROCm with PyTorch 2.0 and beyond. So I'm going to go through three key topics. First, a brief recap of ROCm PyTorch. We're going to go into who we are as an organization, a clear understanding of what ROCm PyTorch is, where you can get it. Next, we'll go to some enhancements to PyTorch 2.0 and beyond. And finally, we conclude with some exciting news regarding AMD Radeon GPUs and PyTorch. So to get started, folks you may not know, AMD and PyTorch, we have a long-standing partnership. We are a founding member of the PyTorch Foundation. We're united by our shared mission to democratize AI through open source initiatives. Our efforts go beyond that. We have a strong commitment to PyTorch. We are actively driving and developing optimizations for PyTorch on AMD GPUs. And I just want to highlight, endeavors like this are a product dedication. And while I've shown some of the contributors on the side there from AMD, it is important to note this is no means an exhaustive list. Countless more individuals across various domains, CI, DevOps, QA, management research, they've all played crucial roles in making this thing happen. So, jumping right in, an overview of ROCm PyTorch. What is it? In a nutshell, it's PyTorch. It's same code repository. We use the same builder as PyTorch, same CI. The only difference, really, if you look at it, is we have one step, one-time process before you build that will convert the PyTorch GPU APIs into the generic HIP alternatives. After that, you're ready to go. Where can you get ROCm PyTorch? The same as vanilla PyTorch. PyTorch.org, there's an install matrix that you can go to on the homepage. You can download PyTorch wheels for nightly and stable distributions. You can download libtorch binaries and follow instructions on how to build from source. One important detail to note with our PyTorch wheels, they come with ROCm already packaged inside of it. So as long as you have an AMD GPU kernel already set up on your box, you can install the wheel and run PyTorch immediately. If you prefer to use Docker, ROCm provides two Docker Hub locations, ROCm PyTorch and ROCm PyTorch Nightly. And if you opt to build from source, as I mentioned, you just need to carry out that one HIPification step, and the rest will go as usual. I've mentioned HIPification, but I don't want to go into it too much because my esteemed colleague and PyTorch enthusiast, Jeff Daly, who some of you may know, did a fantastic talk on this at last year's conference. And so I feel like that would be a much better refresher if you're interested in the nitty-gritty details of what HIPification is. It's only 10 minutes long, so I strongly encourage you all to see it if you get a chance. So moving to key changes to PyTorch 2.0 and beyond. So starting with PyTorch 2.0 and ROCm 5.3, we've added HipGraph support. This feature enables you to capture your model's kernel launches and API calls into a single graph. Easy replayability, no changes needed. Additionally, in PyTorch 2.1 and ROCm 5.6, we added the ability to do print your graphs as dot files using the Torch debug dump API. In the same vein, PyTorch 2.1, we added HipSolver support. This enhancement accelerates a variety of linear algebra operations within PyTorch on AMD GPUs, get improved performance across a wide variety of tasks. But probably the biggest change, and pretty topical for the way this room's been going this afternoon, is our Triton enablement. So starting with PyTorch 2.0, we introduced day zero support for Triton on ROCm. This means that from the moment 2.0 was launched, you could graph compile your models on ROCm PyTorch. Furthermore, the upstream support was added so that stable wheels were produced at day zero as well. So as soon as 2.0 was released, you can download, run, build your models on ROCm PyTorch with Triton. We didn't stop there. What did I just hit? We didn't stop there. What that was. So in PyTorch 2.1, we expanded our support in Triton to enable MFMA instructions, or matrix fuse multiply add. This enhancement allows us to enable AMD's matrix cores to accelerate gem operations and other computational workloads. Additionally, we've added improvements in register file usage in 2.1. This enhancement allows us to leverage, we have larger register capabilities, but slightly smaller shared memory than other GPUs. So we're able to leverage our register capabilities to greatly accelerate a variety of Triton operations, flash extension being one of the big ones. Before we go into some of the improvements we've seen with Triton, I do want to make a very clear note here. To get access to any of these, no API changes from your code is needed. So if your code already uses CUDA graphs and you have ROCm PyTorch, it will automatically switch on the back end to use HIP graphs. The same goes if you have HIP solver support or if you use torch.compile. So let's go to some exciting speedups. So this is using PyTorch's Dynamo benchmark. A lot of you have probably seen that in various talks already today. I picked the Huggingface one just to start with. We trained around 44 Huggingface models across inference and training. And we did it across all three half data types and the mixed AMP. And we did this all on a single MI250 GPU. And so what we show here, a couple keynotes. One, we didn't see a single drop in performance across the board. So every model, even the worst performing one, showed some improvement. In addition, some of the models achieved almost a 4x improvement in performance when using torch.compile. And on average, the inference with AMP showed almost a 2x performance increase across the board on average. Kind of shows the true capabilities you can get using torch.compile with Triton and on ROCm. So moving on to the last topic today. I want to give a quick rundown of what we have already. So currently, AMD ROCm and the machine learning code stacks above it, we're compatible with a broad range of AMD GPUs. Currently on the Instinct line, we're supported on the MI50, MI100, MI210, and MI250. And these are Instinct enterprise-grade GPUs. And then for the Radeon side, we have support for the Pro W6800 and the Pro V620. And as of yesterday, I can now say, with ROCm 5.7, you can now use your 700 XTX and Radeon Pro W700 GPUs on Linux with ROCm. That support is officially extended to PyTorch 2.0.1 with ROCm 5.7, and they're available at AMD.com. I will talk about that in a minute. If you'd like to use the nightly PyTorch wheels or the Docker images I mentioned earlier, those are built to already enable these GPUs. So PyTorch Nightly already supports the correct GFX for the 700 line of GPUs. It's also worth noting that it is the same PyTorch and same ROCm that supports both lines of CDNA and RDNA GPUs. So there's no need to download different versions, anything like that. The instructions stay the same. So if you have a 700 XTX or W700 Pro, setting it up pretty straightforward. These are hot off the press as of yesterday, so last minute slide updates. So first thing you do is go to the ROCm Radeon start page. That'll get you set up with your setting up the AMD GPU kernel. You can install the ROCm SDK from the instruction below. And then for setting up PyTorch, there's a few steps you can go through for the official release. You can go to the ROCm docs and go there to figure out the steps on how to install those. Otherwise, as I mentioned, you can go to pytorch.org to get the nightly wheels and the Docker Hub images to get those as well. So why is it a big deal? Why are we getting a lot of press about this? Main reason is now with these GPUs, we can easily go from desktop to data centers. It's a unified solution with ROCm. Again, there's no stack difference, so your code that works on ROCm 5.7 for Instinct will work on the Radeon side. These GPUs come with a boatload of memory. The 700 XTX has 24 gigabytes. The 700 has 40 gigabytes. of RAM, more than enough to run Stable Diffusion, Llama, V2, other models. And then a lot of the popular ones, because there's PyTorch support, these will work out of the box. So Llama, Falcon, Stable Diffusion I mentioned before, and many more will just work. So I didn't want to leave you guys with just a lot of talk and not a lot of showing. So I put together a quick Docker file here using automatic 1111 Stable Diffusion web UI. Folks have probably seen that before. This is essentially the only real key difference is pip installing that torch wheel that allows you to install PyTorch 5.7 or ROCm 5.7 with PyTorch. The rest is pretty straightforward, and I timed it, and the largest, downloading Stable Diffusion was probably the longest part. And to kind of keep with, in San Francisco, I generated some of these images on my 700 XTX at home. I give you some prompts and what models I used if folks want to try to recreate that or whatnot. But just all of this was done using out-of-the-box GPU. Didn't make any real changes except for installing the AMD GPU kernel driver, which you would use anyways. And yeah, able to get this going pretty quick. So thank you all for coming. Thank you all for having me, giving me the opportunity to speak. If you have any questions, I know these are quick sessions, so please feel free to reach out. I'll be outside the room or at the AMD booth. So thank you for your time.